Happy holidays everyone, and welcome back to Prieto TV. Today we have Prietology, episode 4. It's called The Atoms Family. Last time I told you that today we would talk about atomic structure, like we did in season 1, where we talked about atoms, protons, neutrons, and we got a little bit into bonding. Now we're going to see what those protons, neutrons are made of, and other subatomic particles that are in the particle family. So, like I said, today's topic is atomic structure, so let's review our key terms. Alright, so let's review our terms. Today we have atom, electron, proton, neutron, quarks, neutrino, Higgs Boson, strong force, and antimatter. 9 terms in total, so let's start with the first one. Alright, so let's start with our first term, atom. An atom is a core of protons, which is represented by a lowercase p with a little superscript plus, and neutrons, which is a lowercase n represented by a 0, we'll get to why it's a 0, with electrons, which is represented by a lowercase e with a negative superscript, orbiting it. So everything in the universe is made of atoms, as you guys should know. There are 118 types of atoms because there are 118 elements in the periodic table, which means every element is a specific type of atom, so 118. So, like I said, it's a core of protons and neutrons with electrons. These atoms can lose or gain electrons in chemical reactions. I think we talked about that last season. So, fun fact. The average size of an atom is 1.06 times 10 to the negative 10 meters. So 1.06 followed by 10 zeros, I think. Alright, so our next term is electron. Like I said, electron can be represented also by a lowercase e with a negative sign. So an electron is a fundamental particle, whether you believe it. So it actually has more uses than people think. It is actually, this particle is part of a group called leptons. This is a lepton, and like I said, it orbits the atom core. So this has a negative charge, that's why it has a little negative sign. The number of protons in an atom is equal to the number of electrons, always. These are the particles that are involved in chemical reactions, so these can be given or taken away. Alright, so a fun fact about electrons, the mass of an electron is 9.109 times 10 to the negative 31 kilograms, which is basically like nothing. Alright, so our next term is proton. Proton, like I said, can be represented by a lowercase p with a plus sign. You may think this is a fundamental particle. No, this is not a fundamental particle. This is made of something that scientists like to call quarks. We'll get to quarks a little later after neutron. So neutrons and protons are located in the atom core. They are held together by a force, which is one of the fundamental forces of the universe, along with gravity, strong force. This is a positively charged particle, that's why it has a little plus sign. This, like I said, is made of quarks. It's made of 2 up quarks and 1 down quark. You probably don't know what that means. We'll get to that. Fun fact about protons. The mass is 1.673 times 10 to the negative 27 kilograms. Which is much heavier than a tiny electron. Alright, so our fourth term is neutron. Neutron, like I said, can be represented by a lowercase n with a 0. I'll get to why it's a 0. This, like I said, is a particle in the atom core. This is also not a fundamental particle, but is made of quarks as like our proton. This can only be affected by strong force, which is the thing that holds the atom core together, and gravity. This is a neutrally charged particle, which means it has no charge. That is why it has the 0. No charge. This is made of quarks. This is made of 2 down quarks and 1 up quark. Opposite to what a proton is, which is 2 ups and 1 down. This can usually make radioactive isotopes when you take away some neutrons. The mass of these neutrons is 1.674 times 10 to the negative 27. This is identical, I think, to a proton. Alright, so our fifth term is quarks. This is when it really starts to get interesting. Quarks are basically the building blocks of particles. Protons are made of quarks, neutrons are made of quarks. A bunch of particles out there in the universe are made of quarks. These come in 6 flavors. Flavors means like types. That's what us scientists like to call these. They like to call them flavors. Those 6 flavors are up, down, top, bottom, strange, and charm. You're wondering why they probably call these, right? Like so many weird names, like why strange, why charm, why even call them flavors? I don't know. I'm not a professional scientist. I'm just teaching you guys based on this little textbook, and this little textbook tells me what to teach you, plus I apply some of my own knowledge. Alright, our fun fact is that 2 quarks combined together are a meson, and 3 quarks combined together is a baryon. So protons and neutrons, since they're 3 quarks combined together, they are a baryon, made of 2 ups and 1 down, and 1 is made of 2 downs and 1 up. Alright, so our 7th term is the Higgs Boson. This is a really interesting particle. This is a hypothetical particle, actually. We may not know this actually really exists, but supposedly this particle can give mass to things, so its mass is carrier, the Higgs Boson, named after someone Higgs, some person who discovered it in 1950. Like I said, this may not actually exist. We don't know. We may have found evidence of it, but we really don't know. This could be why there's more matter than antimatter in the universe. We'll get to what antimatter is, because these things usually stream around the universe giving mass to things. So it could be. We don't know. It could cluster around particles and then give mass, because you have to remember, this Higgs boson is the carrier of mass. This gives mass to things in the universe. Fun fact, the energy of the beam that made it, and I think it was made in the Hadron Collider in Switzerland, the beam that made it was 350 megajoules. 350 million joules of energy. What? Alright, so our second to last term is strong force. Strong force is one of the 4 fundamental forces of the universe, and this is the strongest force. Obviously. This is the force that can hold the nucleus of the atom together, because electromagnetism, another fundamental force, wants to repel them away, but strong force has to be very, very powerful to keep them all together, which takes a lot of force. So this can usually make radioactivity and alpha particles. We will get into that next class. Its range is only 10 to the negative power of negative 15 meters. So it's a very small range, unlike gravity, which has an infinite range. Fun fact, its carrier, or the particle that carries it throughout the universe, is called gluon. Gluon sounds like glue. That's what you can remember. Gluon is a character of strong force, because gluon can help hold things together. So yeah, its carrier is gluon, and it helps hold the nucleus together. Alright, so our last term is antimatter. Antimatter is like the evil twin of matter. Like literally, this is the evil twin. It's the entire opposite of matter. All its properties of matter is reversed, except mass. It still has the same mass as matter. But if you combine antimatter and matter together, it'll create an explosion in the universe so big it releases a flash of raw energy across the universe. This mass of antimatter is instantly transformed into highly energized gamma rays. We learned about gamma rays last time. They're super high energy waves that can give you cancer and mess up your cells. So this is gamma ray, but really high energy. Fun fact, the cost of a milligram of antimatter is $300 billion for a milligram. 1,000th of a gram costs $300 billion. You can imagine how much a kilogram would cost if this is like that. Actually, let's do the math. Okay, I got it. It's 300 million billions of dollars in 1 kilogram of antimatter. So that gives you the ridiculous cost, but this also could be a futuristic energy source according to scientists. Well, looks like we finished all our key terms for today, so yeah, there's no experiment for today. So let's just get on to announcements. Alright, so announcements. Sadly, we don't have an experiment for today. Alright, announcement number 1, a Christmas special coming soon this month. We couldn't do a Thanksgiving special because of all this COVID crisis, family, traveling thing stuff. There may also, this year, I'm planning on maybe doing a live stream on New Year's. So if I do one, come and join the fun. Alright, in January, second announcement, January of 2021, there will be a new game coming. It's called Cuphead, right here. I'm going to try playing Cuphead. I'm going to be horrible at it. Well, that's all. Oh, also, one more thing, going back to particles. These particles, like we all talked about, so quarks, neutrinos, protons, neutrons, Higgs Boson, they can all be organized onto one chart. It's called the Standard Model. Can you put another picture up here? Yeah, this. This is the Standard Model right here. So yeah, I just wanted to put that out before we conclude today's episode. Next episode, we will be talking about radioactivity. So alpha particles, beta particles, radioactivity, radiation, Schrodinger's cat, the cat in the box experiment. We'll get into that. Well, I guess this concludes episode 4, so thank you for watching. If you like this video, subscribe and leave a like. Anyway, see ya.